So searching algorithms. We are going to mention big O notation again in this as we go through this. But the first, most direct searching algorithm is the sequential search. That's essentially you go through and you look at every element to see if it's your target. Worst case scenario is that it is your last element in the list. So you have to go through and look at every single element in the list. Best case scenario, it's the first element in the list. Most cases, it's somewhere in the middle. So we go through and look at every element until the target is reached. If the target is reached, then we return the target value. If the target's never found, then typically we return some type of value. Usually it's -1. You might return false if you have a Boolean return. But for arrays, it's actually going to end up being a -1 anyway, so you might as well be consistent. So that's really, really, literally straightforward. The big O on it, if you look at this loop here, it's a single loop, one time through. So if we look at our big O notation, if you guys recall, this is probably, might be asking a lot for this morning, but what's the big O value for this loop? We go back to the code, think about it. So the big O notation here is ON. And it's a linear equation. Direct proportion to the size of the input data. It's always going to be a single loop, is your O sub n. And the worst case scenario is it goes through the list once. Has to go all the way through the list once. Worst case scenario to be considered ON. The reason I say that is because sometimes people look at the next one and they're a little confused as to what the big O notation for that one is. So this is the algorithm for a binary search. The key thing to remember here is that it splits the list in the middle. And the list has to be sorted for this to work. If the list isn't sorted, this can't work. And it says, is the target bigger than the middle or smaller than the middle? If it's bigger than the middle, it throws away the right side of the list, or the smaller side of the list. Just throws it away, doesn't even look at it. Looks at a new list that's essentially half as small as the previous list. Finds the middle again and says, is the target bigger than the middle or smaller than the middle? If it was bigger than the middle, it would throw away the left half of the list and just look at the smaller piece. Divides it in half again. So each time, each iteration through this, it's dividing the list in half. It's getting half as small every time. Until the only thing left in the list is either the target or two items. If it's two items, then one of them has to be the target, and it'll find the target in the next iteration. If there's only one item left, then, well, that's all that's left. It has to be the target. So what we're going to do is look at the code here. This is the code for the computer science exam that they use. We can see it's a while loop. We start left at 0 and right at the last indexed value. That's why we do length -1 of the list. While left is less than or equal to right. So as long as we're not on top of each other, right, and it's not the same single value left in the list, we're going to keep going. We're going to make the middle the left plus the right divided by 2. So that puts the middle always to the left of the list. If you have 3 items, and we do the left plus the right and integer division by 2, that's always going to put the middle to the left. This is an integer division. Don't forget that. It's not double. This is an int. So it throws away that decimal. So we're always going to go to the left side if we have 3 items in the list or an odd number of items in the list, if that makes sense. The middle is always going to be on the left there. We're going to check to see if the target is less than the elements in the middle. We're going to see, is the target smaller than the middle item? Then we're going to look to see if it is. We're going to set the middle to be 1 less than the current middle and set that to right. So that's the right side. We don't need to include the middle. We want to go 1 more than that and kind of throw away the middle because we already checked that. If the target is greater than the elements in the middle, then left is equal to middle plus 1. So we go to the right side. So we're either going to go to the right, take the right, and make it the middle, minus 1. Or we're going to take the left and make the middle minus 1. We're only changing one side of it. We only need to change the left side or the right side. We don't need to change both, because we're either going to the end of the list or the front of the list, one or the other. So if we're going to the front of the list, the right side's fine. It's the left side that has to shift back to the middle. If we're going to the end of the list, the right side's fine. The left side has to shift up to the middle. And that's going to happen just over and over and over again. I almost said the word recursively. You can do this recursively. In fact, anything that you can do with a while loop, you can usually end up doing with some type of recursive algorithm. When we're all done, we're just going to return the middle. Because the middle is going to end up being the target. If it doesn't find it, if none of those if statements are true, then it's going to return -1. I'm just going to tell you what the big O notation is. So that's essentially it for searching. We're not doing much with it, because we're going to go back and hit it again as we get closer to the end of the year. Because really a lot of these things occur with inside classes and objects, which we haven't built up yet. We don't have the knowledge yet to do that, so we're just going to introduce the algorithm. We're going to get more into code with those later. It's not code that you have to memorize. It's code that you have to recognize. So when we get closer to the AP, we'll touch those again. This is your module project. So the module project here is we're using the wild characters. You may have heard of wildcard characters. It's usually the asterisk. So for example, if you're searching for a file directory, the wildcard character, the asterisk.txt, would search through every text file and find every text file that is in a particular folder. So you're to input a string that contains a single asterisk somewhere in it. Then a second string. The second string will replace the asterisk in the first string. Some of you might already have an idea how to do this. But for example, if I entered the string D star G and put in the second string as an in, it would replace the asterisk and get D-I-N-G. Ding. The original string will contain only letters of the alphabet, capital or lowercase, spaces, and tab, and a single asterisk. That's what you're going to be testing on, so you don't have to check for anything else. The replacement string may be any legal string in Java. If the first string does not contain an asterisk, you must say error, no asterisk. You must say that. It must be a specific error message, not just not do anything. It has to actually give an error message if there is no asterisk. If the first string contains anything other than letters of the alphabet, spaces, or tabs, then you have to give an error message, incorrect characters. So you really have 3 problems to tackle here. 1, how do you replace an asterisk with another string? 2, how do you check to make sure there's no characters other than alphabets, tabs, and spaces? And then finally, 3, how do you make sure there actually is an asterisk, and if there isn't, send back an error message. I also want you to do this as efficiently as possible. So you should not dive in and start coding right away. you should spend some time and plan out multiple solutions, different ways of solving the problem. Then I want you to pick the most efficient method that you have discovered that will solve all three problems. Don't dive in and start coding. As we saw with Tweet Tester, several of you made the mistake of just diving in and coding, and it didn't work well. There was much more efficient ways of solving that problem. So I want you to practice that this time. When you go through and look at this project, write down the solution. Use words. How are you going to solve this problem? Brainstorm it. Don't start writing code until you have picked a solution, which means you have to have multiple solutions to pick from. In addition, after this project, we have a quiz for this lesson. And then after that quiz for this lesson, we have our unit test, Unit 3 test. So that will pretty much end grades for the marking period. That doesn't mean we won't start the next unit before the end of the marking period. It just means we're going to stop at Unit 3 for grades. So if you're trying to tally everything up, make sure you have everything completed for Unit 3 to be completed in the grade section. You must also have all the labs that we have assigned so far completed, which should be all of the Magpie at this point, because we did first marking period. And then we should also have part of the pictures lab. I think it only went up to like number 5 or something like that, because the rest we have to wait until we do classes before we can finish that. So those things must be completed as well.